These summary statistics at best tell us how to summarize a data set with a single number. What they don't tell you is how reliable or how consistent is the data set around this single number or the average. The measures of location like mean, median and mode provide us absolutely with no idea about the character of the data. In other words, how it represents the data. That's why we need the measures of spread. In this video, we will look at some real-life applications of measures of spread. So let's jump in. Hello friends, welcome to another video from my channel Learning Puri, a channel for applied learning. I'm Shrish, and on this channel I share with you tips and tutorials to grow faster in your professional and personal life. So if you're new here, consider subscribing to the channel by clicking on the subscribe button, and do not forget to click the notification bell to get notified whenever I upload a new video. I would suggest you watch this video till the end so that you do not miss out on various tips and thumb rules I have shared through the discussion. Alright, in an earlier video here, I had shared with you various nuances of mean, median and mode and where you can best apply these summary statistics measures. You can watch the video by clicking the info card above or the link in the description below. These summary statistics at best tell us how to summarize a data set with a single number. What they don't tell you is how reliable or how consistent is the data set around this single number or the average. Now you would think, why on earth would you want to know the consistency of your data? Good question. So let's look at the performance of the following two sales teams, Alpha and Beta, over 5 months. For both the sales teams, the average sale over 5 months is 75 units. Their total sale across 5 months is the same, that is 375 units. So one would surmise that on an average, both teams have performed equally. If you do think so, then let's look at more summary statistics. Let's look at the range, which is a simple mathematical difference between the highest value and the lowest value in the dataset. For team Alpha, this comes out to be 40, and for team Beta, this is 4. The range is 10 times higher for team Alpha than team Beta. Now this is something very interesting. Let's do one more thing. Let's plot them on a line chart. We see that team Alpha has far higher fluctuation in performance in comparison with team Beta. If we additionally plot a line for the average performance, team Beta has a far flatter line around the average, indicating a higher consistency in their performance across the 5 months compared with team Alpha. The range gave us an indicator of the wide variation in the sales values between the two teams. It therefore gave us some idea of how much consistent one team was in performance with respect to the other. The line chart further corroborates our conclusion. Range is one of the measures of spread. Now that you've understood range and its application, let's look at this another example. Capbot, a manufacturer of bottle caps, has received a quotation from 2 vendors who are selling bottle cap manufacturing machines. Both the machines on an average produce 85 bottle caps per minute and are priced competitively. It is a tough choice for him to make between the two suppliers. Using his understanding on mean and range, he asks both the manufacturers to share the data for number of bottle caps produced per minute at 10 different times of the day on their respective machines. The data on number of bottle caps produced per minute at 10 different times of the day from both the manufacturers is like so. If we calculate the mean and range for the data, we observe that both machines have the same average, that is 85 bottle caps per minute, and the range is 27. This analysis further complicates his decision. Though the arithmetic average and range are the same, he observes that machine 2 had produced more bottle caps per minute in the second half of the day. As he was about to take the decision in favor of machine 2, his production consultant chose to use another measure called the standard deviation. With this new metric, he observed that machine 1 has a lower standard deviation as against machine 2. Further, when the data was plotted on a number line, we see that the data for machine 1 is closely clustered around the mean value of 85 as against machine 2 where it is spread away from the mean. This is an indicator of a consistent performance for machine 1 versus machine 2. So from both these examples, we observe that range provides us some understanding of the spread of the data. Range is also the simplest to understand and easy to compute. However, it is not the best measure to calculate spread since it does not use all the values of the data for the computation. It uses two extreme observations for the calculation that provide no understanding on the spread of the data around the mean. As a result, range fails to tell us anything about the character of the distribution of the data, especially around the mean. With our newfound understanding on using the standard deviation in the previous example of the sales team performances, the standard deviation for team alpha is 15.81 and that for team beta is 1.58. The low figure for standard deviation corroborates our understanding on the consistent performance of team beta without resorting to either plotting the data graphically or plotting the mean alongside the data. With that, here comes the first tip of the day. If you have similar means between two sets of data, like in the case of sales performance, the standard deviation is a good indicator in comparing the consistency in performance of two comparable groups. The two groups must be of similar average size, that is, one cannot compare the mean of a group of people with high income to the mean of a group of people with low income. Standard deviation, simply put, is the square root of the mean of the squared deviation from the arithmetic mean. Therefore, it provides us a better understanding of how far away the data points tend to fall from the center. Unlike range, it also uses all the data for the computation. I have deliberately kept variance out of this discussion essentially since the standard deviation metric evolves around the variance. Moreover, variance is in squared units and intuitively less interpretable in comparison with the standard deviation. To gain elementary understanding on measures of spread, also called as measures of dispersion or measures of variability, you should watch this video over here. The link for this has been shared in the description below and the info card above. And if you have found value till now, hit the subscribe button and click the notification bell. Do like this video so that more like-minded people interested in this topic can view it. Now, if you're feeling more confident about using the standard deviation, let us look at one more example. The following is the electricity consumption for a household with 3 rooms from a specific country located in the tropics. The table depicts the month-wise electricity consumption for 12 months. Here, 1 unit is 1 kilowatt hour, which is the unit of electrical energy consumed in 1 hour. In the tropics, it is not unusual for a household to have higher consumption in the months of April, May and June, when the temperatures range between 35 to 49 degrees Celsius. The temperature tapers off gradually post-June when the monsoon season sets in. As a result, usage of air conditioners, air coolers, and fans increases during these 3 months and gradually decreases later on. If we plot these figures on a number line, we observe something very peculiar. Barring 2 readings at the extreme end of 800 to 1000 units of the number scale, the rest of the data is clustered towards the 300 to 500 units range. We call these 2 extreme readings as the outliers. The average consumption from this data is at about 456.67 or approximately 460 units. The standard deviation for the data is 225.40. On close observation, we note that the average consumption figure appears pulled away farther from the cluster of the data towards the higher end of the scale. Obviously, there is something fishy going on over here, since the average does not correctly reflect the central tendency for the dataset. One of the ways we can handle this is by neglecting the 2 outliers from the dataset and recalculating the average consumption, which comes to 364.8 or approximately 365 units. The standard deviation for this data without the outliers is 39.01. Notice the sharp decline in standard deviation on removal of these outliers. The graph plotted without the outliers also indicates that this new average figure appears to be a more respectable figure. The new mean lies very much within the cluster of the dataset and therefore a better representative of the cluster of the data. Assuming that the two extreme figures were data entry or reading errors, if we replace the two outliers with the new average consumption, the average and the standard deviation of the new dataset will not change drastically. This is just one way of handling anomalies in billing for energy consumption. However, that is a part of an investigation and decision to be taken by the power distribution company. This process of recalculating average consumption and studying the standard deviation can be a time-consuming affair, resulting in an irate consumer. Incidentally, there is another way to work around this problem without expending much effort. From one of my earlier videos over here, I had mentioned that when we have outliers, we should consider looking at the median of the dataset. We will employ the same logic over here. The link to this video is shared in the description below and the info card above. For this dataset, the median comes to around 366 units. Now this looks like a more acceptable figure that represents the central tendency for this dataset. If we employ the concept of quartiles and the interquartile range to study the deviation of the data, we get the first quartile to be Q1 equal to 336.25 and the third quartile Q3 equal to 439.50. Thus, the interquartile range or IQR is Q3 minus Q1, which is equal to 103.25. Despite the two outliers, we observe that the IQR is not affected by them. Further, IQR remains within the range of major cluster of the data. The median apparently is a fairly good representative of the central tendency of this skewed data. The two extreme figures in the 800 to 1000 range do not pull the measure of central tendency and the measure of variation away from the major cluster of the dataset. The interquartile range or IQR cements this point very well. IQR is also a measure of spread. From these examples, we can deduce that using the measure of spread gives us an idea of how well the mean or the median represents the data. Further, if the spread of values in the dataset is large, the mean is not as representative of the data as against if the spread of data is small. This is because a large spread indicates that there are probably large differences between individual scores. Having said that, if you have outliers or skewed values, do not use the range. A single outlier can throw the range completely off. Further, standard deviation should be used only with extreme caution but is better avoided. Therefore, here is tip number 2. In case of skewed distribution, when we use the median, use the interquartile range in conjunction to compare and interpret the values. Alright, till this point we have discussed what are called as the absolute measures of spread or absolute measures of variability. Absolute measures of dispersion are expressed in the same statistical unit as that of the data, such as kilograms, rupees, dollars, and so on. The absolute measures can be used to compare the variations in two distributions provided the variables are expressed in the same units and the variables have the same average size as we saw for the sales performance of two teams. In this next example, we will be using the measure of relative dispersion called the coefficient of variation or CV. This leads us to our third tip in this video. This coefficient of variation measure comes handy when the two sets of data are expressed in different units and or have a different average size. So let's jump in and understand what this means. For instance, a laptop manufacturer, Maple Incorporated, conducted a market research survey on a new laptop they manufactured. The manufacturer wanted to be amply confident about the intent to purchase by the consumer, so he employed two different research agencies to conduct the survey. However, both these agencies used a different rating scale to measure the intent of purchase. Agency 1 used a 5-point intent scale like so, and Agency 2 used the 7-point intent scale like this one. When the results were published, though the purchase intention by both agencies returned high scores, he wanted to be amply certain that the scores were reasonably comparable with each other. Fortunately, he had you as his lead consultant. The following table depicts the mean and standard deviation for the purchase intent scores for the two agencies. We observe that the mean and standard deviation calculated are different for both the agencies. Obviously, they would be different since they are using different rating scales and hence not comparable. Such a scenario where the scale of measurement is different calls for using the coefficient of variation to assess the relative variability of the different characteristics of the dataset. We see that though the average ratings are different, the coefficient of variation for both the results is almost the same. We can therefore safely conclude that the purchase intent ratings between the agencies do not vary drastically and are comparable. Maple Incorporated can now consider launching the new laptop model. If you have noticed in this example, coefficient of variation being a ratio does not have a unit. This is an important factor to consider when comparing two data sets with different units on variability. It is most often reported as a percentage. In a way, it indicates how large is the standard deviation relative to the mean. In general, when the standard deviation is lower than the mean, the coefficient of variation will be below 1 or below 100%. This also means that lower values indicate lower variability as against higher values that indicate higher variability in the data. Alright, if you are feeling like an absolute wizard in statistics, then here's one more example. In the first column from left, I have noted the temperature in degree Fahrenheit. The second column depicts the same temperature in degree Celsius. The mean, standard deviation, and the coefficient of variation for this data is like so. Something is not right. If the temperature is the same, then we would expect the coefficient of variation to be the same as well, right? Well, this is one case where the relative measure of variability fails. Temperature is an interval scale where the concept of absolute zero temperature, or in other words, a lack of temperature, does not exist. As a result, coefficient of variation fails in this instance. To know more about different types of scales of measurement, you can look up my video over here. The link is posted in the description below and the info card above. With all these examples from real-life situations, we can summarize that measure of spread is a summary statistic that has the following significance. First, it determines the reliability of the average. Second, it is basis for control of variability. Third, we can compare two or more data sets on variability. And fourth, it can facilitate the use of other statistical measures. Having said that, here are a set of some thumb rules regarding the usage of different measures of spread. First, use the range for a quick and dirty computation. Second, if you want a sturdier measure with all data being considered, use the standard deviation and the coefficient of variation. Third, use the IQR where there is data that is skewed or with extreme values. Fourth, if you need a relative comparison measure, coefficient of variation serves the purpose very well. That is because the unit of measurement does not matter for the computation, and the average size of the variable can be different for coefficient of variation. Standard deviation and coefficient of variation provide a figure that indicates more reliability of data distribution around the average. And lastly, standard deviation and coefficient of variation are also capable of further mathematical treatment. So they are preferred when such treatment is needed. With that, if you have found value in the video, subscribe to the channel by clicking the subscribe button. Click the bell icon so that you don't miss out on the new videos that get posted. Do like the video and share it with your friends and acquaintances so that you can become a catalyst to increase their awareness on this topic. Alright, moving ahead as a logical continuity to this video, I would suggest you watch this series of videos on probability distribution over here. And here is a video that YouTube recommends for you. Thanks for watching. Till we meet again in the next video, stay healthy and stay peaceful.